Okay, guys, so a quick example about how to do a multi-steps, or what I call a multi-steps. So file new, I'm going to do very quick a beam. I always use the same beam basically. So let's do geometry, curve line, project points, 0 to 60. Cancel, Control A. Now we're going to create the properties, material, new. Let's just do aluminum. Property, we're going to do beam. So aluminum, element, property, beam. Where's beam? Here, beam. Okay. Shape. Rectangular, height of 1, base of 12. We're going to do this type of cross section. Okay, okay, cancel. Mesh geometry, mesh control, size and curve. We're going to do 60 elements. Cancel, mesh geometry curve. There we go. All right, we're going to do this orientation. Okay, I'm not giving too much details, but basically the only means that we only oriented this under this form over here. So F8 XY top. Let's eliminate this. Model, constraint, nodal. I'll go quick because this is not the goal of the video here. Do the model, fix, okay. And now what I'm going to do is model load nodal and say force. And whatever, let's put here force of, I'm going to completely make it up. Let's say it will be 5,000 over here, okay? All right, and let's have this file, save as video model step 1 static. Which is basically solution 101. Okay, so from this solution, the only thing we're going to do is solve for the deformation of this cantilever beam due to the 5,000 pound force. So analyze, manage, new, static, okay, and analyze. All right, so it should be very quick. And the only thing I want to check is this here. So F5, deform. Let's just look at the, we can put total translation, but really I just want to look at the Y. Okay, cut the beam diagram, deform. All right. So how much do we have? 33.65. Okay, the maximum will be this one. So now I want to solve this displacement and rotation as my loading or initial conditions. So in order to do that, you do model, load, let's see, from output. There we go. So we're gonna do displacements. I think now you see they ask you for displacement and rotations. So the X, Y, Z, and you put R1, R2, and R3. Okay, and you click okay. So that's what we have. So now what I'm going to do is save this, and let's just say now file, save as, model, step 2. This is what is called indirect or linear transient. I'm not sure, but let's say this one. And this should be solution. I think it's 109. Yes, 109. Okay, so here what we're going to do is we're going to come here to the loading, and we see we have the 5,000 Newton force that is over here. So let's just delete it. Okay, because now our loading or initial conditions will be the deformation of these ones. And now we're going to see how much time it will take to damp this. Let's say the damping is 0.2 or 0.1, sorry. So that's it. If you want, we can delete this or leave it. I'm going to delete it to simplify. All right, so we have this. Now what we're going to do is change the solution. You can leave this one or delete it. Let's leave it, okay. Manage new. This time we're going to go to the transient dynamic term history. Okay, we have to do something else first. Next. You can change this over these windows, but I'd rather do it from this one here. And let's just go to the next. And this is important one, okay? So you see here force, initial condition, you need to put here force. Basically, will give you all these ones here, your initial conditions. Okay, and done. All right, so model, load, dynamic analysis, Dirac transient. Here, this is for 0.1. You need to put 0.2 because it's 2 times the damping. The frequency of this beam, I know it's about 9. Reason I know is because I calculated in here using a MATLAB code. The first natural frequency is 9. The second one is 56.64. All right, so 9, number of steps, let's say 200 times 10.01, and we'll go to the output 1. And I think that should do it. Okay, and now we analyze. Okay, don't worry about this. This is just because I'm running this not from the computer, but from a shared drive, and it thinks it runs out of memory. But if you see, it was executed, and we have it over here. We have the 200 times steps, 201. And I think the best thing to visualize the data is to come over here, charting, and say new data series versus set. Company ID or set value. I like to use this one. We're going to look at the T2 translation, the Y translation, and let's just look at the tip. Okay, 61, and okay. Okay, so if you remember from the static problem, our initial deformation was 33.65. So when we come to this one, you see this basically, we go to 33.65 probably, and then due to the damping, the response is going to damp to 0, which is what is expected. And this will happen in what? Basically in 1.2, okay? So this should be about what, 1.2 seconds. It will be damp over here. So basically that's it. We first solve the static to get the loading, and then we found the transient solution for that problem. Okay, thank you so much for your attention.